காப்பி பண்ணி வாட்ஸ்அப்பில் வாங்குங்களா? தெரிஞ்சு சப்ளஸ்
because there is no stabilization. You have to have some, it has to compensate the gravity loads. At least 1 MPa loads it should taken at the end of the bottom of the building. For that, unstabilized will increase. The walls will be really around 1 foot, or there are 1 foot to 1.5 foot walls at the bottom, and then it will go tapering on top. So these are the disadvantages of that. And the R&D in India for this earthen buildings is comparatively less. Engineers and architects, they are not really getting trained into this particular usage because of not having good clients for them, and traditional, and also finding laborers is a very big different kind of problematic thing, and hardly any standards and guidelines that can be given for this particular thing. So that's why cement stabilization becomes ideal for coarse grain gravel. So this improves strength, and what happens? Soil plus cement plus water, it forms a gel, calcium silicate hydrogen gel. Over here you see one interesting thing happens. Establishes water insoluble bonds and binds the sand and silt particles. So even when you mix your soil, 15% of soil which is having 15% of clay with your cement and water, it forms a gel. All of us know this, but leaving your clay particles alone. So there is a research that was done by one of my colleagues with my professor, where she could literally retrieve the clay back from stabilized mud blocks. So which means when you can literally retrieve your original kind of material back where during its end of life thing, that means it is sustainable material. This is what I wanted to tell, that rammed earth stabilized mud blocks are sustainable materials as well as green material, because they are using very less amount of cement, and for the manufacturing of that very less amount of cement, carbon becomes less because there is no heating itself, no carbon emission itself in that particular thing. You are using very less cement, so that also contributes to the green element. Over here you are retrieving the soil that is taken from retrieving the soil at the end of life. So it is a green as well as a sustainable material. Few examples of rammed earth. These are the pictures that was clicked by me in Australia at Perth. All these are stabilized rammed earth materials, stabilized rammed earth buildings, which is used widely. And this is something all of you might have noticed. Bhuj earthquake rehabilitation. Here, Bunja house was actually built. Literally 3,000 houses were built in 2 years, in a span of 2 years. Everything rammed earth construction. And this is a 3-storied load-bearing stabilized rammed earth school building that was built in Bangalore, India. Benefits of rammed earth: high thermal mass, noise reduction happens, it is strong, It is durable because of its weight. It is strong. It is durable. Low maintenance. You don't have to plaster it. That brings down the cost. Low embodied energy, no heating, nothing. If you're using mechanical thing, it is only the mechanical tamper. You can also design it for load bearing by not having frame structure. You can also design the whole building to be load bearing. So there will be making it even more green, even more sustainable, because you don't have frame structure. You don't have concrete getting into that particular building envelope, and it is environmental friendly. And it is also versatile in form, texture, and shape. Form in the sense you can have any kind of difference in form, like this kind of forms can be used. You can also see this kind of alcoves can be made. Texture, this is something that is very happily practiced by different architects as of now, giving it a blue, a tinge of green, a tinge of red, whatnot. Different shades of rammed earth by mixing some kind of coloring agents, again in a very small quantity, so that doesn't become hazardous to human health. And you can also include alcoves, which can be used for different purposes. So this brings to the summary of this is just a gist of what a typical rammed earth or stabilized mud blocks would be using. Clay 5 to 30%. I'm being very, wide use of. We don't use 5% of clay. It is usually 15%. This is a summary of the previous work that people had done. Sand again will be around 35 to 75%. And cement 2.5 to 10%. 2.5 is something that we use. The density varies from 1700 to 22 kg per meter cube. The compressive strength for unstabilized rammed earth, you can pay attention over here. Unstabilized rammed earth itself goes around 0.6 to 4 MPa, while for dry stabilized, it becomes 1.4 to 10. And for wet conditions, 0.7 to 4 MPa. So this is the kind of, this just gives a gist of the work that I had conducted in my PhD studies on characteristics of cement stabilized rammed earth. So my core focus was only on CSRE, that is cement stabilized rammed earth alone. So I didn't go to study the mud blocks. Influence of layer thickness in superplasticizer. I came up with what is the optimum layer thickness and how much of superplasticizer addition of how much of superplasticizer can actually decrease the energy consumption. So we've got very beautiful results that can be used in the industry, not just go into the papers. Behavior under compression. So here we understood the stress strain characteristics, and I've also come up with a model, analytical model that can predict the compressive strength of a particular mix proportion without having to do the mix and then make a cylinder or a cube, take that, wait for 28 days and take that and get your 7-day strength and 14-day strength, test it. You can literally put the values into an analytical model and get your compressive strength in dry state or wet state. That particular model, I've developed that model. Then shear strength parameters of rammed earth, bond behavior, and behavior under flexure. So this was my contributing work at ISC in cement stabilized rammed earth. I wanted, yes, so I'll just stop. So I wanted to bring about the understanding, saying on why should we how do we actually select the materials for construction based on what, and how is rammed earth green, how are earth materials green, why are they green, and what are the other solutions that could be used or taken into account for future generations. So thank you all for patiently listening to me, and yes, I guess I took some time, more time. Okay. We started off late also, right?
Yeah. Am I audible?
Yes, Lakeshwari. How do I stop?
Stop presenting. Is there?
I'm not finding that.
The bottom. Did you find it? Next to the send the reaction, next to that.
Why am I not finding it? That time I found it, right?
Yeah. No, you should come out of the presentation.
Yeah, okay.
Just minimize the screen. Yeah.
Oh, it's
Yeah. Yes.
okay.
Stop presenting. Yes, that one. Yes. Thank you, Dr. Lepakshi. You started with defining what is green, and then you went a long way through talking about renewable resources, and then sustainability. Then we ended up in rammed earth. Actually, we are running short of time, so we can have a quick couple of discussions. I think someone has raised their hand actually.
Yes, please.
Mr. Raja Muniyaswamy. You have any queries or any clarification? Now the forum is open. No. Okay, no. He said no. Any other questions? So I think there is no other questions.
Okay, so this brings on to a question whether I put everyone to sleep or whether
No. It was not like that.
whether anyone understood anything. Okay.
You said
anyways.
plenty of information. Anyways, Thank
Okay.
you so much. Thank you.
Okay, thank you all. Thank you for joining, and thank you
Someone
for.
has again raised their hand actually. Sorry, sir, you can unmute yourself and you can speak, sir.
Yeah, very good morning. And there is a small question.
Hi,
When
sir.
speaking about, hello. So when speaking about this sustainable and green building, in the slide number 18, I found that you had been talking about that. Can I just go to that?
You want the slide?
28.
28. I'm not sure if I have to present again, right? Logeshwari, I need to present again. right?
Yes. You have to present. Only then he will be able to see it. And you can minimize the screen.
Yeah. 28, is it?
Yeah.
This one? Is it visible, sir?
No.
No.
It's visible for me. I think it will come there.
Okay. Yeah, is it visible?
No, still not.
Still not. No,
No, Dr. Lepakshi, you just keep it there. Maybe his network
Okay.
is a little bit slow. We'll just
Is it visible for you, Logeshwari?
Yeah, it's visible.
Okay. So it's visible right now. Kindly check.
No, I'm just finding the.
Okay, you can go ahead with the question.
Anyhow, I will just make it clear. You spoke, ma'am, about the carbon emission due to the cement and extra adding of the cement. As you said that the owner is forced to put more cement or like that something, and which will increase the strength. And actually, it is a part of. It is not economic, and you are using the other person's material, or it can be not proper. At the same time, what you would like to speak about the steel? Because see, steel is such a material that which can be reused, as we can say that, even after kept for a long period of say 2 years or 3 years or so, if it is having a proper tensile strength, what would you like
Yes.
to suggest about this?
It has to be used. We need
Yeah.
to. It has to be used. Undoubtedly, it has to be used.
Yeah.
Undoubtedly, it has to be used. It has to be stored in the right way again. Steel
Okay.
cannot be just left in the environment, allowed it to rust like anything, and then tell that, okay, I have steel and you can use it. It's no more steel, right? If you have, then you are again going to make it so cost. You're going to increase your cost by cleaning the rust out of the steel, because rust is going to, even if you leave small amount of rust in your steel because you have left it in an open environment, that is again going to cause damage to your building.
Structure. Yeah.
Yes.
Yeah. No,
So
but
anything
what to
that
say?
can be-
Extra provision of steel. What you would like
Extra
to say?
provision of steel shouldn't be used, because we always go in for over reinforcement, under reinforcement. No, we should go in
Yeah.
for under reinforcement
Balance.
only, always.
Under enforced or balance steel. Okay.
Mostly.
But if the steel is being used, that is the old steel, which is costed earlier in a very less cost, and from the point of view of what I can say, reusing, it can be little bit a percentage, 10 to 15%, maybe in that case less only, but can it be used? That is what.
Sir, it can be used. Probably there we have to make some kind of analysis where we can use it for your roof structure and not your columns.
Okay. No, what has been, why I'm asking, because actually one of my projects is going on in which we are using this steel, which is a Tata 500D ductile steel only. And we went for the testing of that steel for the bending as well as the tensile strength both, because if during the bending, if it is become brittle, it will crack out, na?
Yes.
So there are
That's
no cracks at all. Yeah.
exactly why we have to use. It should be stored very properly. That is very important.
Yes.
Or if you have the idea of storing, you can also have. Now you have a lot of paints that will rust-free paints that are there. No, that can be used on the steel material.
Yes.
Yeah.
So that costed that time hardly 34 rupees when we got purchased, and now presently the steel is to 84 rupees.
Yes,
Definitely,
skyrocketed. Yes.
Rocket, yeah. So that was cut steel which was purchased by the owner, and which was having a proper length, actually 4.5 meters. Even then it was sold out, and that's why he has purchased and kept it. So we tested it, and then we reused. But a little bit, what you can say on a higher side, we thought that providing this steel, whether we are going on a, say, as you said, over enforced, I think it would be a little bit good one, because.
So that depends on what your structural engineer will tell, because I can't comment without not knowing any numbers. But I would really suggest you to keep it well within your balanced steel and not go to your over reinforcement itself. Better keep it under reinforced, because now recently, I'm not sure whether you saw a building that collapsed over here in Bangalore. That is due to different issue, but there's a lot of things that is happening. Collapse, literal sudden collapse happened. Over reinforcement, that is what will happen. So if you're having more steel, you paint the steel and keep it aside, but please don't use if it is increasing your steel amount. Please keep it under reinforced or balanced. Hello? Hello, is he around? Was I audible?
Yeah, you were audible.
Okay.
I think his connection.
Some network.
Yeah.
12 o'clock.
Okay. So if that is it, shall we wind up? Is there any other comments or queries from the participant sides? I think there is nothing. Anyways,
Okay.
Once again, my hearty thanks to Dr. Lepakshi for giving us an elaborate and very lucid presentation.
Thank you, Dr. Logeshwari. It was very nice, and I am really happy to collaborate with you on this platform. It's nice to, by the way, Logeshwari was my junior at Indian Institute of Science. So we know each other for quite some time.
Yeah.
So it's nice to see you over here, and all the best. Thank you.
Thank you. So participants, we will wind up the session now. We'll meet in the afternoon session. Thank you.
Yeah. Thank you.
அப்போ 4 மணிக்கு ஆன்ல இருந்துச்சு. எந்த மைக்கு எதுன்னு தெரியல.